recording. All right. Welcome, friends. It is week 4, lecture 3. After today, we are officially halfway done with the MERN / JavaScript stack. So give yourself a pat on the back. This is usually a time that I just tell students to reflect on where you were with this knowledge 4 weeks ago. Probably you had no knowledge, would be my guess, because you probably hadn't learned this language yet. Maybe you had a little bit of knowledge because of JavaScript. But now you've understood routing and you understand full stack applications and a whole bunch of stuff. So usually this is a great midway point that I always instruct students or encourage students, I guess, to reflect on that, because sometimes it can feel like, man, I'm behind or I'm not understanding stuff. But really you should be very proud of yourself because you've gone really, really far and you've understood quite a bit, especially if you're keeping up with the assignments and you're all the way up to this time. You've understood quite a bit, which is amazing. A little bit of housekeeping. We have discussion questions, which are due Sunday. We have our core assignments. There's 3 of them. Those are due Sunday. Again, as always, you can find those here in week 4. We have these 3 assignments, your Axios Pokemon API. We've learned how to do that. We should know how to do that. Routing practice, which we've done, and then Faker API. Now, there will be something that I'll talk about Faker API here in a bit. But those are your 3 assignments that we need to do. Just as a reminder, I'm just going to keep reminding you, next week is a break week, so there's not going to be any TA help. I'm going to be off. I'm out of office. So if you are needing help, you can put stuff in the Discord. That's great. If I'm available and around, sometimes I check Discord, but I try to, if something is, if it's a holiday, I try to be present with that. So just wanted to remind you, and then also let you know again that TAs are not going to be here either. So it's just going to be a break week. Again, if they're in Discord, you put a question, maybe your classmates can help. And if a TA hops in just for fun, then maybe they'll help you. But I'm going to be kind of self-reliant next week. Following that, we're jumping straight into week 5. Today, what we're actually doing is we are going to go over MongoDB. So I do this a little bit weird or a little bit different. And the reason is because, and this is kind of why I was talking about Faker API. Faker API is a fine assignment, but really what you're doing is you're manipulating data that is kind of like on the front end, right? And like a array or however you want to do it. I think you instantiate a person and then you kind of add that to an array. That's not really what we're going to be doing. So what I like to do is, on the second day of Express, we haven't gone over update and delete, and that's intentional because really doing update and delete on something that is not with a database does not make sense. You're never going to do that. Like that'd be just be silly for me to teach you and then turn around and teach you a totally different way. So what I'll do and what we'll do is we've already talked about folder structure and routing. We've already done all of this. So what we're going to do is we're going to introduce MongoDB and Mongoose today. And then after, which means week 5, we're going to start actually building our full stack stuff. We're going to start connecting and seeing, okay, I'm going to set up my back end. I'm going to have a database. I'm going to start saving to the database. And then how does that work? How does that operate? Then we can update, delete. We're going to use Mongoose to do all of that. So yeah, just wanted to give you a heads up there. That's what we'll be doing today is we're actually going to be doing MongoDB because again, you're not ever going to do this without a database. That doesn't make sense. So I'm not going to teach you something that you're never going to do because it doesn't make sense to me. So yeah, that's what we'll be doing. And then next week, or sorry, not next week, but the week after, we're just going to be preparing, seeing how it all connects, MongoDB and the back end. And then that'll be 2 days of that fully, doing, creating and reading in our database. Next day, we're going to be doing updating, deleting, maybe some filtration, kind of getting certain things if we wanted. I try to help you guys with the exam at this point, where I might just say, cough, cough. You might want to know this. A little birdie kind of told me, and then that might be like a black belt feature or something that you'll need to know for the exam. And then on Thursday, what we'll start doing is building out our full stack application. So we will be taking kind of like 3 days to do that. And then Thursday, I reserve that for any sort of belt exam questions that you guys have, any sort of extra materials I want to go over to kind of help you guys again with the black belt or with anything you're not understanding, reiterating, kind of creating errors or seeing errors or kind of processing through that. So that's what Thursday will be. And then our exam will open. So just as a reminder, you need to have 11 core assignments done in order for you to qualify for a belt exam code. So what'll happen on that Friday is I'll go through, I'll run it. And then at around noon, I'll see, okay, who's got 11, and then I'll send you a code. If you didn't get a code, then you've got until about 5 o'clock. You need to email me and let me know, hey, I finished my assignments. Can you check it? I'll go in and check it. And then we can get you a belt exam code for that first weekend. Cool. Any questions on any of that and what we're going to be doing today? Again, today's pretty light. We're just introducing MongoDB and Mongoose. We're going to be using MongoDB today. I'm going to kind of poke around, show you what it looks like, show you how to do everything, but we're not really doing any heavy lift. But any questions on what we talked about there? Okay. I'm required, so please don't think that I love to do this. I'm required to set aside some time for a mid-stack survey. I know I talked about this yesterday, but if you guys could, it's super helpful for me, super helpful for Coding Dojo, for us to do this. So I'm supposed to set aside, we're supposed to set aside like 10 or 15 minutes. I usually set aside like 5 to 7. So that way it doesn't take too much of our time. But what I will be doing is pausing the recording. The mid-stack survey is in our chat right now. You can also go to our sheet and do that here. I'm going to play some music, and then in about, we'll give it 8 minutes. So at 5:15 my time, we will get started. So let me pause the recording. Okay. So recording has now resumed. So we're going to jump into our kind of recap and then really our agenda for today. So if we can remember, we recapped let's recap kind of what we did yesterday. We talked about Express, and we talked about how Express and our node backend, our server side, is really going to become our API, right? And so we built that out. We installed Express on our backend. We created a new folder called server. We had a server.js file. We ran a specific command to get a package JSON file. Can anybody remember what that command was? Can anybody remember it? Very close, Brittany. It's npm init-y. But yeah, exactly. Same. Yeah, we run that npm space init space -y. And what that does is that creates a package JSON file for us that just says what our dependencies are. And then after that, we can download Express or install Express or do whatever we want. We set up an entire, we set up an entire Express folder. We had some information where we are bringing in an Express. We are creating an instance of Express called app. And then we decided what our port was. We built in some routes. We talked about how our routing has two kind of things that it has. It has the actual route itself, and then it has a callback function. That callback function has two parameters, our request and our response. Our response is if everything goes well, it's a promise, right? So if everything goes well, here's what we want to respond with. We could also, when we were dealing with post requests, we handled our rec.body or rec.params. To kind of see the information that we're getting. So that way we can go and grab some information if we wanted. And at the end of our server.js file, we used app.listen and then said the port we had. Again, we stated that if you didn't want to create this, you could just put 8,000 here and that would work just fine. And then we said listening on our port. So, and then we ran it and we talked about nodemon.js or nodemon, sorry, which allows us to continue to run. So anytime we make a change, it's going to restart our server and make sure it can be updated with the most recent information, which is great for us as we're developing and testing. I built out some routes where we had our get routes and our post routes. So we handled some of that. If you are curious, the update or the patch and delete is here as well. So same. Again, I'm not, they're on the platform, so those are available for you. And we don't have this correct amount of information or the database. So I don't necessarily show that until we have the full thing together and we can kind of see how that works. And the last thing is we have some folder structure. This is not something we talked about, so I want to talk about it right now. When we built this out, all we had was one server file that kind of had everything in there. What we're going to be doing is actually building out even more kind of abstraction. We're going to segment every portion of our code to make sure, okay, we have the information that we need. We're going to be talking a lot more about this next time we meet. So not next week, but the week after, because we're going to actually start building this out. But it really consists of 4 folders plus 1 file. We're still having our server.js file that's still going to have all of that information. We're going to have a config file or folder, sorry. And that config folder is going to have our configuration file. Now, again, we're going to talk a lot more about this, but this is a way that I can connect my database to my API, right? And so that way my API knows when I'm calling some data, this is the database I'm trying to talk to. We have our controller files or folder. That's going to be all of our logic. So if I wanted to do anything, and let's say that we have like a movie and I want to get all movies, I can do that here. My models is going to be my movie model. So if I'm creating like a form, right? And if I want some validations, I want to say every movie needs to have a title, needs to have a year, needs to have a how many Oscars it's won. However, whatever I want to do, I'm creating this blueprint of what each movie in my database is going to need. If you guys have dealt with Java or Python, then you're familiar with what that looks like. Creating a model, creating sort of a blueprint of this instance here. That's what the models will be. And then our routes, right now we had routes in our server.js file. We're going to abstract that to its own just sort of routes folder. And then within that's going to be a file. So what's nice is if we have multiple things, let's say we have users and movies. So a user can log in, they can add a movie, they can update a movie, they can say that they've watched a movie. Well, then this abstraction allows us to understand, okay, if my route is having to deal with my person, I can go into my user. We're going to have a file for user routes or my user controllers. And so what it does is allows us to debug and problem solve that. We're kind of piecing it together and putting it at the beginning. We're putting it in a way that if there's ever an issue, we can pinpoint much, much faster than if it's one monolithic meaning that's all just one big file, because it gets a little bit harder to be like, okay, where's this route? Where's this going? So it just is a way for us to kind of categorize our code, so that way it can help us in the future. But again, we're going to be really hitting all of this next time we're together. So if you don't know what this is, that's a-okay. You do not need to know right now. There's lots of different ways to do it. So you might see like your module exports done in a different way. Also a-okay. We'll be really talking about that next time. Cool. That's a little bit of a recap of what we've done. We've talked about kind of what's expected, your assignments, your discussion questions. And so what I want to jump into is your database. So we're going to look at MongoDB here for the next 40 minutes, maybe 40, 35. And so we're actually going to look at MongoDB Compass. We're going to start breaking that down. This is going to be our database. Again, my friend Caden was kind enough to lend me some of his slides. And so he likes writing it out in a way that I think makes a lot of sense. So kind of what is a database? I think most of you guys this is not your first language, but if it is your first language, then it's a way that we can organize a collection of data and we can store it and access it electronically. Really, it's just like a big filing system, a big storage system for us to have some sort of data that we can retrieve later on. These databases can be run on your computer. They can be run in the cloud. They can have on-premise, meaning you have your own server. There's lots of different ways that you can kind of handle that. Everybody's kind of moving towards the cloud, but because it's cheap and easy. So, but again, it's like a storage system. Instead of having a physical copy, it's just electronic that we can go and query and grab some information from. Now, if you guys are from Java or Python, then you are familiar with the image on the left. This is what we call a SQL table. Now, there's really 2 big main categories of databases. One is called a relational database, and the other is called a non-relational database. So those are kind of the 2 big ones that we're going to be talking about and dealing with. What a relational database really is that if I've got some sort of relation between my entities. So let's go back to my person and my movie. If a person creates a movie and I want to know who is created or who created that, then I would create a relationship between those two tables, between those two instances, right? On the left here, you see what we call a SQL table. Tables are rows and columns. And so what the table is called, and we're going to see here in a second kind of the different words, but what really this whole thing is a person table, and it's got different columns, which is ID, name, surname, and age. And then each instance is represented by a row. So my first instance is Jody Tucker. That is row 1. And so they have an ID, and it goes 1, 2, 3, 4, et cetera, et cetera, et cetera. Fun things about relational databases is if you delete a user, it does not go backfill. Like, let's say we're at ID 35 and I delete Jaden. It doesn't, the next one doesn't go to ID 2. It just continues on. That number is now gone. Now, some of these, this is kind of like an older school ideology. I mean, still very popular, so don't hear that. But it's kind of rigid. So in every instance, within my table of a relational database, so every row must have the same exact columns of information. So even if, let's say that I have a name and surname, but in the middle I have a middle name, right? Well, let's say even if somebody doesn't have a middle name, maybe they just have a first name, maybe they're just, the person's Seal, right? They don't have a middle name or a last name or surname. Well, even if that's the case, they must still have a value at the middle name and the surname. And so it creates a little bit of rigidity. So even if, the data doesn't match up, we have to compensate for that. And then it can create kind of an issue there. Now on the right is what we call a non-relational. You'll hear it as no SQL and no SQL. Now, this does not mean that it is not SQL. What the NO stands for is not only SQL, because you can technically, on certain databases that are non-relational, you can still use SQL queries to query them. You can use tools like Athena within AWS to do stuff like that. But what this is saying is, hey, this is, I'm saving some information, and we can save it in a way that's a little bit more dynamic. What do I mean by that? Well, first and foremost, let's kind of look at some of the names or naming conventions, and this is on the platform. I'll show you here in a second, of the differences, right? So here, we've got our database, right? And same, we're going to have a database within SQL. But instead of what we call our table, our person's table, we've got what we call collections or collections. And so there's same sort of thing. So if I want all my employees together, my addresses, my departments in our non-relational database, we're using MongoDB, but there's a ton of different types. There's different types within non-relational as well. So things that are not document-based like MongoDB. So this is not the only one. I just want to point that out. But we have collections, and then within that, each, instead of what we call like our instance or our row, we've got a document. Now, this document can be fairly fluid and dynamic, meaning that if we have that same issue where Seal comes up and they are, they don't have a middle name or a last name, it's okay. It can expand or it can shrink, and the data does not have to be the same. So it gives us a benefit there. Now, that's not always beneficial, right? We want to make sure we have all the optimal information, but with each database, there's no perfect situation for each database. You have to figure out, okay, where does it ebb and flow? What's the most optimal for my group and for my people or my situation? Cool. So within, I want to hop in here first before we go back to that slide. So a couple different things with that. When you're installing, if you have Windows, you can just follow this and install version 5. So make sure you install version 5.0. But if you're on Mac, version 5 is no longer supported. So you need to make sure you download 6.0. So what I would say is, regardless, whichever type you have, Windows or Mac or Linux, right? It would be considered this. Follow this code and make sure that you do not kind of just assume, because again, this is 5, not Mongo 6, but here on our Mac, we need to have Mongo 6. Cool. Just want to point that out. Again, there's a couple different nuances based on what we call it. So with our database in a Mongo, we just call it a database in MySQL or in SQL, because it could be MySQL, it could be PostSQL, it could be all sorts of different things. You call it a schema, right? So that's just kind of your build. If you've got a bunch of different types, so we had employees, addresses, all that, we'd have employee tables, address table. In MongoDB, we call it a collection, like we just saw. And then each time, again, we have a different row or record or instance. We just call that a row or record, but in MongoDB, we refer to that as a document. Cool. And this slide is great, or this, sorry, not slide, portion of the code or platform is great because it'll kind of go through those. If you've never dealt with a SQL database, then it might be kind of a foreign language to you and it's not really comparing anything that you know. So don't really worry about it. If you want to look at it, that's great. But just want to make sure that you guys aren't super confused there. Cool. Now, one thing to note is when it stores data, let me go back to actually to this slide. When MongoDB stores data, it looks like a JSON object, right? Which is great for us. That's what we've been using. That's what we've been dealing with. That's this guy right here. Reality is it's not, it's what we call BSON. But from all intents and purposes, you can just handle it like a JSON object and it's binary JSON. That's just how a database stores it. But just so you know, that's kind of in the weeds. You don't really need to know that. Just treat it as if treat it in the same way you treat a JSON object there. Now, there are a couple different things that we can talk about, and we're going to look at. There is a lot of information on kind of how to create a new document, create a new database, and how to create a new collection, all that kind of native Mongo code. I would say that this is a great thing to learn in the future, or to if you're bored or over this break, feel free to dive in and learn that. It's not inherently necessary because we're actually going to use something called Mongoose that is going to fix a lot of this stuff and make it much, much easier for us. So if you find yourself getting confused here with this guy, that's okay. We're not really going to be dealing with that. But you can follow along and see the different aspects of updating and deleting / destroying is what it'll be called. So, but we're going to be using what we call Mongoose. And Mongoose is just going to allow us, really, it's like somebody wrote all the code for us. And so instead of having to do this native sort of vanilla Mongosh stuff, we can just call certain methods or certain functions in order to do that. So it's really, really nice that if I want to update or delete, I can do like .find, and that'll automatically do everything that, that kind of native code that MongoDB has. In the same way that whenever you dealt with, if you guys took Flask, you had to write the actual SQL code, right? You had to create and say, when I say this is my actual code. It's like somebody's already done that for us, and we just get to reap the benefits and just call the function, which is really nice. Okay. What I want to do is jump through, because we don't really need to work on validations yet. That's going to be something that we build whenever we build our model. So next Tuesday, we're going to start building models, and we're going to kind of be coming back and forth into, okay, we have this express, we have this model. Let's build with some validations and let's start building this stuff out. So, what I want to do is just point out that when you download MongoDB, you will get something called Mongo Compass. So you should be prompted to get Mongo Compass. You don't have to have it, but I would say that you kind of do in order to pass this class. As long as you have to have MongoDB. Like if you don't have that, it's going to be very, very, you can't do it. Secondly, if you don't have MongoDB Compass, it's going to be really challenging because it's just a way that we can see data and make sure everything from like a dev perspective. So if I were you, I would download it. And if you didn't get that prompt, if you've already done it, sorry, every time I talk a lot, I yawn. And you don't have that downloaded, you can just type in, I believe you can just type in MongoDB Compass. Yeah, you can type that in, and it's just a GUI. It's a graphical user interface. I'll put this in the chat for you. So that way, you can actually see what's going on with your MongoDB database. Now, again, you could interact in a way that's sort of native, where you can kind of query and see what's going on. And if you add something, does it work? But it's much, much easier to use this. So I kind of wanted to give you a visualization of what that looks like. Great. So when you download it, this is not what you're going to see. Let me see if I can come out. I just want to go to the very basic portion so that way we can kind of all do this together. Okay. So what'll happen is you'll get something like this, and this is your what we call a connection string. When we start dealing with config files, this is going to be really important. You don't need to edit or change it. You can keep it as is, and I would encourage you to do so. At least for right now. You don't need to create a new cluster or anything like that. It should, once you pull this up, and if you have MongoDB already downloaded, you should be A-okay. And so once you see this, we want to make a connection to our database. And so we click that connect, and then here we've got our actual MongoDB sort of instance. And this is all of our databases. You should all have an admin, a config, and a local. I've got this MovieDB and then some old stuff from RFID dashboard, but you should have at least these three, and that should be okay. Now, if you create a new database, when we get into the config file, we can add something, create a new database. If you don't see it or it's not there, you can click this little refresh button. I'll do that. Or if I wanted to add something, I can do that right here, right? Where I can create a database name, and then I want to create a collection, and then we're A-okay. Cool. Now, let's look at my MovieDB database. So this is my actual database itself, this MovieDB. And within that, I've got this collection of movies. Right? So I can click on this, and here you can see all of the movies that are currently in my database. Now, a couple different things. I can use Mongosh right here if I wanted to use sort of that native code. Again, if I want to do that. You can type a query here as well, which is kind of cool. It's just, again, allowing us to interact with our data. But what I want to show you is really what each of our data or each portion of data has. There's a couple things that we use or we add, a couple things that we don't add. So I just wanted to show you what happens. So here you can see that each instance in this case does have the exact same field, and that's what's going to happen with us. Again, I know that I said that it was flexible, but in what we're doing and what the exam is, they're all going to have the same different fields. But it's just a key value pair. And what I've got is a couple different things. I'm going to come back to this, but I've got my title, I've got my genre, and I got my year. Now, when we start dealing with our models and we're creating what we're wanting to do, right? Or saying, okay, every time I'm creating a new movie, it needs to have a title, a genre, and a year. And I can create some validations, right? To make sure I have good data. I also can add in two pieces of information, this created at and this updated at. Can anybody think of maybe why we would want these two pieces of information in our database, especially for those that have already taken a full stack language? Or maybe have an example of why each one. Go ahead.
Oh, sorry. I was going to say version control might be a reason to have both of them and keep them on record. But if you're updating information, like let's say, I don't know, turns out Walter Mitty was made in 2014 instead of 2012.
Mhm.
then if a user were to update that, then you could say, well, the created ad is still the same, but the updated ad is now has a new time.
Yeah. Yeah, that's a great example, Joseph. Thank you so much for that. Yeah, it's a way that we can just kind of interact with our data and interact with our users can interact. There's also lots of other just kind of nuancy things. So you can think of created at if you've ever been a part of something and it's like, hey, happy 1 year anniversary. You're now part of blank, right? You've been part of Nike.com for 1 year. Woohoo! Here's 10% off. They use a created at, right? That just basically run some sort of functionality. They query all their data and all the users that were created that day, and then they send them an email. Same sort of thing with like password management is where this updated at happens. So like, especially with the cloud, oftentimes every 90 days, you have to change your password. And so again, companies will use this updated at to say, when was the last time that this was updated? And if it's been more than 90 days, then they know, hey, this person has not updated their password in at least 90 days. There's other things that they can do too, because people could get around that and just like update their name. But same sort of idea, right? If I wanted to see when was the last time this was updated, or hey, is this old data? Is this new data? Is this prior to something happening? I can kind of look at that, right? And adjust there. This dash dash V is just our version. Here it's just like a versionality thing for MongoDB. It's no big deal. But then the last thing I wanted to talk about was this ID. Now, in the same way that if we were dealing with our SQL database, we had an ID, and you guys all know that an ID or a primary key is really, really, really important. Here in a relational database or SQL table, it just goes 1 through X, right? Or in however many instances we have. MongoDB operates a little bit different, and it just has a random string. So there is no sort of rhyme or reason. As you can see, it does not go like to 3D to 3E or anything like that, but this is still your object's ID. So again, it is still my unique identifier. You can sort of think about it if you are, if you were if you're a US citizen, then you've got a social security number, right? And that is unique to you. There might be a million Will Calhouns, but there's only one, hopefully, Will Calhoun with my social security number. Um, Same sort of thing. It makes sure that we know which instance that we are actually dealing with based off of the ID, based off of if somebody logs in and we can see their profile and et cetera, et cetera, et cetera. So it is known in MongoDB as underscore ID, and this is automatically created for us. We don't have to kind of put that. Same thing with this version portion. Those are both automatically created. We don't deal with that. We don't say, hey, we need to have an ID here. It just is inferred. These other ones, these 5, are what we will end up in our model actually building out and showing. Cool. Let's see, is there anything else? I think I had one more slide. Yeah. So again, this is a great example of Mongo versus Mongoose, where with Mongo, we might need to do something like this. We might need to say db dot the collection name, so users or whatever it is, dot find, and then we query our document. Whereas Mongoose, we can just say user. So let's say if we have an instance of a user that's associated and there's a collection called user.find, and then it returns to us a promise. And if we can find that user, we have a dot then, and we do some sort of logic with it. And if not, then we get an error, maybe saying, hey, this doesn't exist, or this user, whatever, et cetera, et cetera. This is sort of like an ORM, an object relational mapper, to where kind of, sort of, but really you can think about it. Somebody else sort of did some of the heavy work, and create it and set it up in such a way that we can actually manipulate and have the data a much, much easier way, and kind of gives us a lot of power. So that's where Mongoose is really going to come in. Again, it's going to be much easier for you. If you do want to try your hand at Mongo stuff, you're welcome to. And there's lots of stuff on the platform. When we're dealing with operators, you can look at all of this. And again, I would encourage you, like if you have the time this next week, look at it, start diving into it, seeing, kind of how you can manipulate it, how you create your own database. Because that's not going to hurt you. Having that knowledge is not going to hurt you. But if you're kind of stressed and you're saying, I need to pick and choose what my time has, I know it's holidays and family and or work or whatever, then I would say that this is less important in starting to understand Mongoose, the Mongoose commands. So like finding all users is just .find. If we want to find one where the user's name is Jessica, I say .find, and then I pass in whatever piece of information, or find it with the user whose ID is blank, and we can, or right here, right? Find one. So there's lots of different Mongoose methods that we can use, and then there's find one by ID. There's lots of different things that we'll get into as we start building this, and I'll tell you, hey, this one's a little bit better, or this one's a little bit more deprecated. So let's in the future, let's aim towards using, I think it's find user by ID or find one by ID is a little bit better than find one. And they all kind of work in a different way. So, and then we can just like save stuff, which is creating a user. So again, the functionality is a little bit easier with Mongoose than it is just natively doing it with MongoDB. Cool. We will get into validations. This is what we're going to be doing with when we start building out our model. But just to give you sort of if you guys have done validations with Java, or if you've done Python, they kind of sucked. Like it was pretty hard. Really easy here. Very, very easy for validations. All we do is we create our user schema. So this is going to be our model. We say, what is the key of that? And then if we have validations, we just say it must be a type string. Is it required? Yeah, that's true. And then must have a first name. The minimum length must be 6. And then if it's not, here's the message. So if you guys have ever dealt with validations, if you didn't like validations in Python, this is going to change your life. It's going to be much easier, which makes it a little bit easier and more fun for us as well. But again, we're going to start diving into, we'll create a model on Tuesday of the following week. Our next time we're together, we'll create a model. We'll start diving into validations, really start putting this stuff together. I just wanted to introduce you today, maybe let you out a little bit early, but introduce you to MongoDB, to Mongoose, so that way we can start the wheels, and you guys can kind of say, okay, I understand this is a document, collections, and I understand how this relates. So that way, if you guys do want to work ahead, you can actually have that knowledge. Cool. Are there any questions on MongoDB? It is a big database, so it's huge. So it's not like this is everything we know or everything there is. MongoDB is one of the world's most popular, I would say, especially for non-relational. There's other ones like DynamoDB that are kind of cops or kind of similar to them. I think that's like Amazon's. But MongoDB works in the cloud. We've got all kinds of stuff. So it's a very, very big application, and we're just kind of scratching the surface of it. But it's really, really powerful. Really, really, really powerful. So really cool. Okay. Any questions? Can you guys put a 1 in the chat if this all makes sense? Put a 0 if it does not. Okay. Well, that's all I have for today. Are there anything I can help with? I can help clarify before I send you off and we have a break week next week.
Not a question about like the material, but will you be able to open up the discussion questions for the next 4 weeks for us?
Yes, I will have to do that Friday because there's another class that's currently, I can't do it until Friday, but I will try. Let me pause the recording. Any other questions? Yep, absolutely phone. I'll put the link to the survey in the chat again, but it also is on our, if you can't do it right now, it's on our class sheet at this mid-stack survey, but I just put that in the chat for you. I appreciate it. And again, yeah, anybody that's doing that, I really appreciate that survey. It really helps. All right, friends. Well, I hope you have such a wonderful weekend. I hope you have a wonderful holiday week, a break week. Be kind to yourself. Give yourself a little bit of a break. You guys are crushing it. Have a great Thanksgiving if that's what you celebrate. Have a great Diwali if that's what you celebrate. I hope you guys have a great time. And if you need anything, feel free to email. If it's urgent, feel free to email me. I have email on my phone and I can kind of help you out there. So, all right, guys, have a wonderful time. Talk to you soon.